Hi, welcome to my channel. In the previous video, we discussed about the MNST dataset, MNST dataset, dataset, training a binary classifier, training a binary classifier, and measuring the accuracy, measuring accuracy using cross validation, and confusion matrix, and then we discussed about the precision, recall, and F1 score. In this video, we are going to discuss about what is the meaning of precision and recall trade-off. Okay, so here increasing the precision, it will reduce the recall, and vice versa. Simply this process is called as a precision recall trade-off. So now, for example, what is the meaning of precision? Precision equal to based on the confusion matrix, precision equal to true positives by true positive plus false positive. Recall is nothing but recall equal to true positive by true positive plus false negative. So based on this information, we are going, if we increase the precision, that will reduce the recall. If we decrease the precision, it will increase the recall. So simply this process is called as a precision recall trade-off. So now to understand this one trade-off between the precision and recall, let's look at how the stochastic gradient decision classifier makes it classification decisions. For instance, it computes a score based on the decision function. If the score is greater than the threshold value, that means, for example, here the stochastic gradient decision classifier predicts some score, computes some score based on some function. That function is called as a decision function. If that score is greater than the threshold value, then it assigns the instance to the positive class. Otherwise, it assigns to a negative class. Okay. So simply this is called as a precision recall trade-off. So for example, here this is about the precision recall trade-off based on the one threshold value. So here there are three types of threshold values are there. This is a threshold 1, for example, this is a threshold 1, and this is a threshold 2, and for example, this is a threshold 3 value. Okay, for example, now from this one, above are positive class and below are negative predictions. For example, here in the precision, okay, the total number of elements in this class are here 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 classes, how many 5 classes are there? 1, 2, 3, 4, 5, 6. That means 6 by 8. That is 75% of precision. Recall means the total number of positive elements. The total number of positive elements are, that means 5 class elements are 1, 2, 3, 4, 5, 6. All the things are right on all the positive class on the right side of this threshold only. That means the total number of elements, positive elements are 6 that are classified based our threshold value as a positive class. 6 by 6, that is 100%. So initially the precision is a very low value, recall is very high value. And coming to second threshold value, here the precision is equal to 4 by 5. That means the total number of elements in the right side of this threshold value is 5 elements are there. Out of 5 elements, 4 elements are correctly classified as a 5 class. That is 4 by 5. That is 80%. And the 4 by 6, that means the total number of positive class in the entire data set of 6 elements are there. That is 1, 2, 3, 4, 5, 6. six elements are there, and out of 6 elements, about the threshold values, so how many positive elements are there? 1, 2, 3, 4. That means 4 by 6. 4 by 6, that is equal to 67%. That means the threshold value increases from left to right. What happened, ma? The precision is going to be increases, the recall is going to be decreases. So here coming to third threshold value, okay, here the total number of elements on the entire right side of the threshold value is 3 elements. So all the 3 elements are correctly classified as 5 elements. That means 3 by 3, that is 100%. Whereas coming to the entire data set contains the 6 positive elements are there, about 6 positive elements. Here on the right hand side only contains 3 elements positive elements are there. That means 3 by 6 positive elements are there. Okay, that is 50% of the elements are correctly classified as correctly classified. Okay, here that means as a threshold value increases from the left to right, okay, the left side of the threshold value becomes negative predictions, and the right side point becomes positive predictions. So this is the way we are going to differentiate between the precision and recall. So here the precision is going to be from the at initial stage, the precision value is going to be very low value, and recall is going to be very high value. As the threshold value increases from the left to right, the precision is 100%, going to be high value, and the recall is going to be low value. So simply this is the relationship between the precision recall trade-off. It gives the relationship between the precision recall trade-off. Okay, now. So now our figure shows that a few digits are positioned from the lowest score on the left to the highest score of the right side. So suppose that the decision threshold is positioned at the central arrow, that is at the central arrow, okay, between the two 5 elements. Okay, you will find that 4 elements are 4 true positives are there. 1, 2, 3, 4. 4 positive elements are, the actual elements are 5 on the right hand side of the threshold value. So 1 false positive element. Okay, that is 6 value. So now, therefore, with that threshold value, the precision is 80%. That means 4 by 5. 4 by 5. Okay. But out of 6 actual files, the classifier only detects 4 elements. The out of 6 positive elements, only the classifier detects the only 4 as a class 5 elements. Okay. So the recall is 60%. That is 4 by 6. 4 by 6%. If you raise the threshold value, that is moving to the arrow on the right hand side, the false positives become the true negative, thereby increasing the precision up to 100%. Okay, but one true positive becomes a false negative, decreasing the recall down to 50%. Okay, so lowering the threshold value increases the recall value and reduces the precision value. Okay, so scikit-learn does not let you set the threshold value directly. So, but it does give you the access to the decision score that uses to make a predictions. So instead of calling the classifiers predict method, you can call it its decision function method, which returns a score for the each instance, and then use the any threshold value you want to make a predictions based on those scores. Okay, so here y underscore score equals to y underscore scores equal to stochastic gradient classifier decision function of some digit value. That is we are going to display the y underscore score values, that is 2412.53. This is the your threshold value. Okay, your score value. Here the threshold equal to 0 value. Y underscore some digit underscore predict equal to y underscore scores, that is greater than equal to threshold value. Yes, that is true. So the stochastic gradient classifier uses a threshold value equal to 0. So the previous score returns the same result as the predict method value. Okay, let's raise the threshold value. The threshold value is going to be 88,000. So y underscore some digit underscore predict value equal to y underscore scores is greater than the threshold value. So y underscore some underscore digit underscore predict value is a false value. In this confirmation that raising the threshold value decreases the recall value. the image actually represents as a 5, and the classifier detects it when the threshold value is 0. So, but it means that when threshold value is increased to 80,000. So, how do you decide which threshold to use? Okay. First, we use the cross underscore val underscore predict function to get the scores of all the instants in the training set. But this time specify that we want to return the decision scores instead of the predictions. Instead of predictions, we are going to use the decision scores. Okay, y underscore scores equal to cross underscore val underscore predict value based on the stochastic gradient classifier. This is the model of our model, and the x train and y underscore train underscore 5. The cross value is equal to 3, method equal to decision function. Okay, with these scores, use the precision recall underscore curve function to compute the precision and recall for all possible threshold values. So from the sklearn dot matrix, import the precision underscore recall underscore curve, precision, recalls, and thresholds equal to precision underscore recall underscore curve. You have to provide the training data and the corresponding predicted value. Okay. So y underscore train underscore 5, comma y underscore scores. So finally, we are using the matplotlib to plot the precision and recall as the functions of the threshold value. So definition of plot underscore precision underscore recall versus threshold. Here for that we are providing the precision, recall, and the thresholds value. We are plotting the plot thresholds comma precisions between colon to -1, that is all the rows. Okay, comma b the type of the line, and label equal to precision, and plot thresholds recall all the rows, and g the color of the line is equal to g dash, label equal to recall. So here plot underscore the precision underscore recall versus threshold. For that we are providing a precision, recalls, and threshold value. We are showing the plot underscore plot dot show. Okay, so here as the threshold value increases from the minus 4,000 to minus 40,000 to 40,000 towards positive side. So here initially the precision is low value. It increases to to 1 value. Okay, whereas initially the recall is very high value. But while time goes on, while threshold value is increased from the minus 40,000 to 40,000, okay, towards the positive side, the recall value is going to be positive 1 to and the negative side. Okay, that is 0 side. Okay, that means so the recall is going to be decreases, and whereas precision is going to be increases. So you may wonder why the precision curve is bumpier than the recall curve. So the reason is that precision may sometimes go down when you raise the threshold value. To understand why, okay, look at the we are going to have the figure at this location. Okay, and notice that it happens when you start from the central threshold value and move it just one digit to the right side. Okay, precision grows from the 4 by 5, that is 80%, to down to 3 by 4, that is 75%. On the other hand, recall can only go down when the threshold is going to be increased, which explains why its curve looks so smooth. Okay, another way to select the good precision recall trade-off is to plot the precision directly against the recall. We are going to draw between the precision versus recall directly. Okay, so that is shown in the figure 5. So you can see the precision really starts to fall sharply around the 80% of the recall. We will probably want to select a precision recall trade-off just before that drop. For example, at around 60% of recall. Okay. Now, but of course, the choice depends on your projects. Suppose if you decide the aim for the 90% of precision, you first of all you look up the first plot and find what you need to use the threshold about the 8,000. To be more precise, we can research for the lowest threshold value that gives the at least 90% of precision. np.argmax will give the first index of the maximum value, which in this case means that the first true value. So threshold underscore 90% precision equal to thresholds np.argmax precision is greater than equal to 90%. At that time the value is 0, okay, 78, okay, 7816. So to make predictions, instead of calling the classify predict method, we can run this code. Okay, we can run the code. So y underscore try underscore predict 90 equal to y underscore score is greater than equal to threshold underscore 90 underscore precision. Let's check these predictions precision and recall. So precision score y underscore try underscore 5 comma y underscore try underscore predict of 90. So that is a 0.90. So here the recall score is a y underscore try underscore 5 comma y underscore try underscore predict of 90. So that is a 0.43. So we are going to have a 90% precision classifier. So as we can see, it is fairly easy to create a classifier with virtually and any precision you want. Okay, just set a high enough threshold value. Okay, but wait, not so fast. Okay, a high precision classifier is not very useful if it is recall is too low. A high precision classifier is not very useful. Okay, if its recall is too low. So in the next video we are going to see ROC curve. Thank you for watching our video. Thank you.